So here we are. We made it to the end of the chapter. So on this part, we're going to close up by seeing how we can have a broad classification of chemical reactions. So that's what we're going to do. We're going to classify chemical reaction by recognizing some specific patterns. So let's start with this problem, and I will go over all the patterns that we need to understand. Classify each chemical reaction as synthesis, decomposition, single displacement, and double displacement. So those four patterns will allow us to classify most of the reactions. For example, I can tell you right now before we begin that precipitation and neutralizations, those are double displacement reactions. Combustion is a combustion is a combination reaction or a synthesis reaction. So synthesis is also known as combination. A lot of the redox reactions are going to be single displacement reactions. So let's see the patterns we use. Synthesis follows this pattern. A plus B producing C. From many, few. So you can combine several things into one. So that's the pattern that synthesis or combination follows. Decomposition is the opposite. From one, many come out. So decomposition is, like the word said, breaking apart. Single displacement, you can have something like this, where one of the elements on the second compound is displaced. So the A displaces the B. So only one gets displaced. So double displacement is going to be something like this, where everybody gets replaced. So A goes with D, and C goes with B. So if you can recognize those four patterns, then you know which one we're talking about. So let's go ahead and do that. Let me do something here real quick. Let me do something once more. So here are our patterns. So AC creates A and C. Single displacement ABC creates AC plus B. And double displacements AD plus CB. And I believe we are missing synthesis, where A plus C produces AC. So let's see what we have here. On the first one, we see that the K goes with the nitrate, and the cobalt goes with the sulfide. So this one follows this pattern. So this is going to be double displacement. You're also going to be able to call it double replacement, whatever works better for you. The second one, we get A plus B producing C. So that's going to be synthesis. The third one, the zinc goes with the chloride. which means it effectively replaces the cobalt. So this is going to be single displacement or single replacement. And the last one is going to be where something becomes two different things. So this is going to be decomposition. So if you can follow those patterns, you can classify the chemical reactions on these very, very general terms. So whenever we start talking about neutralization, precipitation, redox, and combustion, then we are being very specific, and several of those can fall under one of these categories. So with that said, that's your daily work. So make sure you use the patterns that we just learned. And with that said, you have pending more practice. You now know how to classify chemical reactions, which brings us to the end of the chapter, where we can see that we can recognize when a reaction happens, color changes, smell, temperature, light, and all that kind of stuff. We can count the atoms on the formulas and see if the reaction is balanced. And if it's not balanced, we know how to write the reaction using the names and then balancing. We learned how to use the solubility table to determine if a compound is going to be soluble in water. Basically, the ions separate. And once we do that, we can use double replacement, like you just saw me doing, to take a reaction and do a precipitation reaction, as long as one of those compounds that you're producing, according to the solubility table, is supposed to be insoluble or a solid. And to do that, we have to be able to break anything that is aqueous into the ions that it makes. We can eliminate anything that repeats on both sides, and what results is the net ionic equation. And the equation done with only the formulas, not showing any of the ions, that will be your molecular chemical equation. And then we saw how we can do that specifically for acid-base reactions, and we know that some of the acid-base reactions are going to produce gases, so you need to have those notes always handy or know that from memory. And then we saw how by seeing changes on the charges, we can identify if a reaction as being redox or not. Then we learned the pattern for combustion reactions, and we just learned now the pattern to classify very broadly the different chemical reactions that there are. And with that, we close the chapter. And that's it. So after this one, you have your spring break. So enjoy it. I will be working on chapter 8 during the spring break. So be ready to start chapter 8 as soon as you come back from your spring break. So see you later. Have a great week.